All right, we're going to look at page 69 and 70 on your guided notebook. On page 69, they talk about we're talking about exponential growth and exponential decay in this case. So carbon-14 dating is an element that naturally builds up in plants and animals during life, and then will decay exponentially after death at a rate of 11.4% per millennia. So what we're going to be doing is figuring out the decay factor, and we're going to be using that information to find some other parts. So use the equation factor equals 1 plus or minus the rate to determine the decay factor for carbon-14. So 11.4% is the percentage, is the rate. So we're going to do 1 minus, because it's decay, 1 minus 0.114, which is 11.4%, which is 0.886, which is the same thing as 88.6%. Okay, so now when we have this example, at year millennia 0, the carbon dating is 100. So assume that you have 100 grams of carbon-14 to start with in the following table. So this is what they're doing. And then after 1,000 years, or 1 millennia, we would only have 88.6 carbon-14 remaining. And you get that by doing 100 times the rate, or the factor, raised to that power. So we talked about this in the previous sections where we were talking about the initial times the rate raised to the year. Okay, so the initial value is 100, the rate is 0.886, and it's raised to the second millennia, or second year, would be 78.5, and then for the third millennia it would be 69.55. So the formula that we're actually using here is what we were just talking about, is that 100 is your initial value times 0.886, which is the rate, raised to the m, which is the millennia. So now if I put this into a graph, so this represents the graph of that information, you'll notice that it's a decay because it's declining. So here's our trend line up here, and you notice on our trend line it says negative 0.121, and then it says r squared equals 1, which means it's a perfect exponential function. So what's the continuous decay rate? That's the negative 1.121. So when we write it, we don't write negative, because we're talking about it's a decay rate. If I said it's a growth rate, then it would still be 12.1. It just depends on whether I'm talking about decay or growth. So use that equation from your Excel and your e to the x button on your calculator, or the exponential button, to compute the amount of carbon-14 left after 8,250 years. So the first thing we have to know is that the value of m in our formula is the millennia. So 8,250 years is 8.25 millennia. So when I do my problem, I'm using this formula up here. I'm doing 100 times e raised to the negative 0.121, parentheses, is my time, 8.25. So when I put all that in my calculator, I get 36.85. So that's the amount that would be left in the carbon-14 left after 8,250 years, which is 8.25 millennia. So I hope this helps.